Hello everyone, welcome to the presentation Foundational Concepts in Large Language Models. In this video, we'll explore the key components that make a modern AI language models like transformers, self-attentions, positional encoding, pre-training and loss functions. What is the transformers? Transformers introduced in 2017 and it replaced RNNs and long short term memory with parallel processing based on encoding and decoding architectures. Key features of self attention of mechanisms, efficiency for long range dependency in the test. What is the encoding and decoding? Encoding is the understand the input, decoding is the generates the output. Encoding decoding architectures is the backbone of the transformers models. It converts an input the sequence into the initial representations and then generates the output sequence and step by step and encoding process the input test. Each layer has two main sublayers and encoding transform to the multi-head self-attentions to the feed-forward and multi-head self-attentions to the input, and decoding mask multi-head attentions to the encoding decoding attentions to the feed-forward to the output. And what is the output generates? It examples like translations and text communications. And what is the self attentions? Self attentions helps the model understand the relations between words and regardless of their distance in the sentence. For example, in the sentence, the animal don't cross the street because it was too tired. The word it refers to the animals. Self attentions assigns attentions cross to each word, showing how much each word should be focused on others. This enables the model to capture the context and meaning efficiently. What is the positional encoding? Positional encoding is a transformers process. Words in sequence like RNNs, they need a way to understand the order. That where positional encoding comes in, it adds a unique signal to each token emitting based on the positions in the sentence. And uses of sine and cosine functions for positional patterns helps the model understand the word or order. Suppose some of the examples that cat sat on the mat not equals to the on the mat sat on the cat. What is pre-training and fine tuning? It is large language models are trained in two main stages. One is pre-training stage, another one is fine tuning stage. Pre-training is where the model learns general language, understand from message to text datasets like books, articles, and the internet. For example, GPT learns to predict the next word in the sentence. And fine tuning where the pre-trained the models is trained the future specific tasks such as translates of summarizations, question and answers. Fine tuning allows the model adapt the domain specific data with relative small datasets. There are two stages of process save time and resources while achieving high proficiency. Suppose pre-training follows to general knowledge, fine tuning task exercise. What is loss functions and cross entropy? To train the model, we need to measure how well the predictions match the correct answer. This is done using loss functions. For language models, the most common one is cross entropy loss. It is measures difference between predicted probability distributions and actual correct word. The mode tries to minimizing the loss by adjusting the parameters to the back propagations. And common language models are cross entropy loss. And for example, prediction to the cat sat on the dash predictions might be target mat. Suppose loss equals to minus log of 0.9. Right now I'm concluding here. Thank you so much for watching the video.